Okay, cool. So before we start demo, I'm not sure if everyone's done this yet. Um, so let's get started by first installing Docker. Can everyone do that real quick? We'll just wait while people finish that up. And then ideally, if you have the time, you can also make an account on Docker Hub, but that's something we'll use on Wednesday, so it's not actually necessary for this lecture. And while people download Docker, I know when I took the course, this was like the most confusing lecture. I didn't really understand it at all. And I literally just thought of this analogy when Jessica was giving a lecture. But images and containers are like the two components of Docker, right? And the way I thought of thinking about it is just like you have the App Store, right? The App Store is equivalent to Docker Hub. When you download apps from the App Store, you're pulling from the Docker Hub. And the image you get is like the new app that you just installed. Everyone has the same version of the app when you install it for the first time, right? So the image is like a template. It's like what you initially start working with. And then when you open the app, that's the Docker container. The container is a live instance of your app running. And as a user, you are now then able to like mess around with it and like actually interact with the app. So hopefully that like makes like understanding this a bit more sense, because I remember what like I was really confused when I learned this. So yeah. Show of hands who's not downloaded Docker yet. Okay, we can still wait some time. And then the environment thing we were talking about, right? The environment is basically the bare minimum you need to run the app, right? So your operating system, your code, your libraries, and environment variables are the bare minimum you need to run your app. So for example, if you're on a phone, right, you need an iPhone OS, you need an iOS, right? That's otherwise you can't run the apps you want to run. And you need the code that runs behind the app to actually run the app as well, right? And the reason why Docker is so nice is because, for example, on my computer, right, I have Spotify installed and like Google Chrome installed and all this garbage that you don't actually need to run the app. A Docker image contains only the bare minimum to run the app, meaning the operating system and your code and etc. Which is why it's so like simple and modular, and is easily kind of passed around across developers. That makes sense? Cool. Anyone still downloading Docker? Very good. Okay, if you have Docker downloaded, make sure you open it before you start this demo. So yeah, that's just the last step before we can get started. Okay. We're good. All right, so I will start with demo now. So the first thing we'll do is just open our code from demo 4. If you weren't here for last week's demo, you can just go ahead and download the starter code from last week. That only has like the hello world endpoint, but that's really all you need, because we're not actually coding out an app this time. So yeah, open demo 4 code. That's this file right here. Okay. Everyone good? All right, let's start. So the first thing we need to do to actually start like this process of creating a Docker container / image is to create this thing called a Dockerfile. The Dockerfile defines how you want to actually run the app. So again, going back to the App Store analogy, right? Let's say you want to open Facebook or like Instagram or whatever. You as a user shouldn't need to know to run app.py or pip install requirements.txt, right? All you have to do is like tap the icon. In similar fashion, when you have Docker images, the way you run them is by running a command called docker run. So it kind of like whether you have a Python project or a JavaScript project or a Java project or a TypeScript project, every type of app you run under Docker, like you can run it with docker run. So it like kind of modularizes this process of running the app, right? So again, let's create our Docker file. and this will define how to run our app. I'm going to activate my virtual environment just to check my Python version, but this isn't actually necessary. You don't have to do this. Okay. So now we have to now build our Docker image, which is like our template or like our blueprint for running the app, right? But we have to use like a base template. We can't make something from like absolute scratch. And a lot of the time, the base template will be the language that you're using. So in our case, that would be Python. To define the base template we're using, we're going to use the from command. So to do that, we type from in all capital case. Also, in this Dockerfile, make sure the D in Dockerfile is capitalized and everything else is lowercase. There's no extensions at all either. So there's no like .py. Okay. So from Python colon, and then I'm just going to use the version that I have in my virtual environment, which is 3.9.12. And this is the base image. You can actually see the image that exists on Docker Hub itself. So if you go to Docker Hub and you're signed in, you can type in Python here to look it up. And you'll see that Python has like its own base image, right? And then if I look up 3.9.12, that is indeed a version that exists. But you don't actually have to know this nitty-gritty detail. You can just copy me if you don't understand that part. So for working with our base image of Python 3.9.12, the first thing we're going to do is to create a directory for us to like store our files in. This is because a lot of the time when you have a computer running some sort of service, you'll have a lot of system files, and you don't actually want that in the same directory as your app files. System files being like, you know, your computer just kind of creates a bunch of files to like make your computer run a little smoother. And you want to kind of distinguish that and like the app files that you're running. So we'll first make a directory for containing our app files, right? All right, so the way we do that is by using the run command. Run just runs a terminal command in your image, your Docker image. So if let's say I'm in my source folder right now, right? And these are the files in my source folder. One of the commands that's a terminal command that a lot of you might use in the future is mkdir, which stands for make directory. And you followed it up with the directory name that you want to use. So let's say I'm just going to call it test. Right? If I do mkdir test, then you can see that a new file called test was created. Everyone see that? Right. So we're going to do the same thing here. We'll make a directory called app/user/app in our base directory. And the way we set this directory that we just created as our working directory, i.e. the directory that we're going to be hosting all our app files in, is by typing a command workdir user/app. And ignore the exclusive for now, doesn't really matter. Then the next thing we want to do is to copy all the files we have in our source folder and move it over to this user/app folder. And the way we do that is just by doing copy, the copy command. And this takes in two inputs, the first being everything you want to copy, and then the second being where you want to copy it to. So everything I want to copy is in my current directory, so I'll just type dot. And then the directory I want to store all those files in is also the current directory because I set the working directory to be user.app earlier, so it's just another dot. Okay, so this is actually all of our setup that we need. In the Docker image, we're basically in the source folder, but like the Docker image version of it. So to run our app from, right, from like to run our app, we have to first install our requirements, right? That's the first thing we did in demo 1. So we'll use another run command and type pip3 install -r requirements.txt. And then once we've installed all our requirements, all we have to do is run the Python file, right? Which is app.py. You might think that you would use a run command here, but that's actually not the case. The command you use to run your actual app or run your actual server is the cmd command. And you can only have one CMD command in your Docker file. That determines what file you want to be running when you actually call this Docker file. So CMD python3 app.py. So hopefully that makes sense. So this is everything that's going to be in our Docker file. And if let's say we're not using like Python, right? And we're using like say TypeScript instead. And our our installment steps are like npm install and then like npm run. Then like that would go in here as well. So the Docker file determines or defines how to run the steps individually. And then once we actually define that, we don't have to memorize these commands ourselves. We can just run Docker run and it'll run the app smoothly. Cool. So now let's build our base image, right? Our image, i.e. our app, right? Like the template version of our app. So the way we do that is by typing docker build dot. And the dot is saying the current directory is where my Docker file is. So I'll do that. And I think this might take a bit longer for you guys to run it. I already have Python installed. Like I loaded the Python image previously, so it's like cached in my system, but it's okay if this takes a little longer to build for you guys. In the meantime, I'm going to demonstrate how to see all the images that we've built. So we just built an image, right, from the current directory that we're currently in. The way we check what images exist is by typing docker images. Okay, wait, let me just delete this image from earlier. Docker image. Okay. Whatever. This is the one that we currently have. So let's just focus on that. The one that was created 49 seconds ago. So is everyone done building their Docker image? Show of hands for those who aren't done. Okay, we can wait a little longer. Any questions about how Docker works? Yeah. That's just like what we arbitrarily chose. It doesn't actually really matter what we call it. But again, in any given image or like computer, right? A lot of the time the computer will make system files, right? Files so that your computer runs smoother in the base directory, in the very root directory that you're in, which is where your default directory starts at. So we just made a folder called user/app to like store all of our app.py and db.py in so that it doesn't actually get like mixed up with all the system files. So that doesn't really matter what you call it. You can call it whatever you want, but yeah. Does that make sense? Anyone's still building? Okay, that's okay. I'll still demonstrate the next command, but it's still going to be a Docker build command, so don't worry. So one thing you might have noticed is that in the Docker image that I just built, I have no repository name and I also have no tag, right? I just have an image ID. And this image ID is like, not something that's like very easy to memorize. So a lot of the time we're going to want to define a repository name or like an image name to, associate to each of our images. So that we can better identify what each of the images are. So the way we're going to do that is by typing docker build -t, t for tag, and then we'll put the name of the repository. So when you actually make a Docker file for PA5, you have to prepend your username to it. So like my username on Docker Hub is snajima. So when I build it, I have to type snajima / some sort of name. Otherwise, it's not going to upload on Docker Hub, so be careful of that. That's just one thing to take note of. But yeah, let's just so I'm just gonna do snajima and then demo 6 or no 5. to add as my repository name. And I still have to define where I'm building this Docker image from. So that's, again, the current directory, hence the dot. And now if I do Docker images, you can see that the image that I just created 3 minutes ago has been replaced with the name SNajima demo 5. Okay. This tag thing is also pretty interesting. So a lot of the time when you're working on a project or working on an app, you'll have multiple versions, right? As you work throughout like the process of this development stage. So this is like the latest version of my demo 5. But let's say I have like a version 1 and like a version 2 that I want to distinguish, right? If you're doing something like that, when you Docker build it, you can add a colon at the end of your repository name and type your tag name. So if I do like v1.0.0, right? And again, that's the command. Colon and then tag name. If you do Docker images, you can see that a version 1.0.0 has been created. And if I build a version 0.0.1, right, then like a new version has been created. So if you don't define a tag, the latest will be used by default, but otherwise you can actually define the versions that you're working on to better keep track of like the application that the process of the application that you're working on. Cool. Is everyone like done kind of playing around with building Docker images? Everything makes sense so far? Yeah. Amazing. Okay. All right. So now that we have these Docker images, right, let's actually run them. Right. Again, going back to the analogy, right? The way we run an app on our phones is just by tapping them. The way we run a Docker image is just by typing Docker run. And then the repository name. So when you run a Docker image, unfortunately, this is a bit cumbersome and something that you have to remember, but you have to take note of what port you're running the Dockerfile in. So in app.py, note how every time we ran app.py, it ran on port 8000, right? So that's why you were hitting localhost 8000. We have to actually define what port to be running our Docker image in as well. So the way we do that is by typing this the flag -p for port. And then we map the port 8000, which is the port number in our Docker image, to port 8000 on our computer. So if let's say this was 7000, then the first value will be replaced with 7000 because the image port number would be 7000. And then 8000 is a port we're trying to actually access on our computers. And then we'll type /IT for interactable. This way the terminal in the Docker image becomes interactable. And then the repository name. So SNajima demo 5. Okay. So I'm going to leave this command up here. But we've just run our first Docker image. Amazing. Anyone still copying down this command? We're good. Okay, so you can see here that now like something seems to be running, right? This looks really similar to what is outputted when we run app.py. And in fact, it is. So let's go to Postman and try to hit one of like our demo 4 endpoints, right? Let's say get all tasks. If we hit send, you can see that it's running the app just like we ran, just like it was running when we ran app.py, right? So our Docker image, which is the template, has successfully been converted to a Docker container and is now running. Okay, cool. Also, one quick thing I forgot to mention is before you build your Docker image, we want to prepare our code to be production ready, right? So this means deleting our virtual environment like we do with our submissions of like the homework, deleting PyCache, and so on. So I forgot to do that, so I'm just gonna do that real quick. I'm gonna delete all of these. Right, and let's build the Docker image again, or yeah. So we have a version 1.0.1. we want to update this with version 1.8.2, which is like a clean version. Let's do that. And now we actually have a very clean version with containing only app.py, db.py, our Dockerfile, and requirements.txt. So we'll run that instead. Version 0.2. And you can see that now the database is all cleared. We have like a blank slate to work with. And yeah, now like, so this image right here, I'm able to like share with you guys, and you guys would be able to download it. And instead of having to memorize pip install and app.py or like Python app.py, you would just Docker run it, right? And again, the reason why that becomes so convenient is because if, say, I'm working in a different language or a different framework or a different package, then you wouldn't have to remember the setup steps. All you would have to do is run Docker run. Okay. Any questions? That makes sense. Cool. So the next thing that actually, I don't know if we have time for that. Okay, let's just do it. So the next thing we're going to cover is the Docker Compose thing that Jessica mentioned during lecture. Docker Compose makes this step even easier. So right now we're running Docker run, defining our ports, defining that it's interactable, and then defining our repository name, right? Like, yes, this is easier than having to remember setup steps for individual apps, but it's still kind of a lot. So we can even more like modularize this even more by using Docker Compose. So Docker Compose tells us how we can run individual images on what port and what kind of configuration. And some apps, like Jessica mentioned, have multiple images in it. So let's say Google Maps for an example, right? Google Maps has a calculator, right, that like determines how long it would take between two locations. It has like some sort of map view that like displays the map to you, right? It has bus information that it would have to like pull from a separate API. It has all these services that's running at the same time. And in the industry, you would want to kind of have all of these different compartments in different images to like kind of segment them out. And when something breaks, right, you can quickly identify which part of the app broke. And so that would be an example of when you would use multiple Docker images, right, in a singular app. For the scope of this class, we're only going to be using one image, but in a Docker Compose file, you can define as many images as you want in any configuration as you want. And instead of running Docker run -p blah, 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 it'll be an even simpler command. So I'm just going to make a Docker Compose.yaml file. Docker, again, that's Docker/compose or -compose.yaml, YML. And this is going to be where we define which images to run on what port and all sorts of other configurations. But we're running a bit low on time, so we'll start the Kahoot for today. Let's just end it with an empty Docker Compose file for today. Yeah. So any questions before we move on to the Kahoot? Hopefully I wasn't going too fast. Hopefully that made a bit of sense. Okay. Okay, so we are on week 5 demo. Ooh, let's go. This is the second last one. So just a little recap, right? Show of hands, was anyone not here on Monday? 1 person, 2 people, 3. Okay. So on Monday we covered containerization, which is a way of kind of wrapping up a lot of your code and like your app into like this like standard unit of software. And so what that means, right, is I made an app store analogy on Monday as well, so I'll make it again. But every app you download from the App Store kind of has a similar format, right? On your phone, at the end of the day, it's just like a little box with a little with this like logo on it, and then you tap it to open it, right? It's kind of like that. You like put it into like a little container, and that way we don't depending on like the project we're working on, we don't have to like remember to do pip install on Python app.py, etc., etc. Yeah, it's a little hard to kind of summarize the entire lecture in like a few minutes, but Just take a look back at that if you need to. Otherwise, the other thing we did was using our demo 4 code. We made a file called the Dockerfile and wrote these commands in it. So I guess if you want to copy this down, you could quickly do that. Or you can take a photo. So yeah, anyone feel like they need a recap on containerization before we continue today? Show of hands. Or are we good? Yeah. Yeah. No need? Are we good? Okay, awesome. So again, we made a Docker file, right? The Docker file contains instructions as to how to run this app. Oh, also one thing I quickly forgot to mention. Jessica's not here today, unfortunately. She is out because she's sick. So let's hope she feels better. But yeah, so I will be giving demo today by myself. Anyway, with that out of the way. So the Docker file contains instructions as to how to run our app, right? So we have a base image, Python 3.9.12, that we define in the first line. We run the command make directory user/app. So this is going to be the folder that we're going to be containing all our files in. We set that as the working directory. So this is where we actually run the app from, where we copy the files to, et cetera, et cetera. Line 6 copies over all the files that we have in the current directory on my computer to the actual image. So app.py and db.py are 2 of those files, right? And requirements.txt. Then we run pip install requirements.txt to install the dependencies onto our image. And then finally, we run python app.py. Yeah, any questions about this file? Does anyone remember what the difference between run and cmd are? Yeah. Yeah. Yeah, that's perfect. That's exactly correct. So cmd, you only have one in each Docker file, and it basically runs your app, right? Run are terminal commands that you run before to kind of set your app up. So that's what the difference is. Okay, hopefully I showed the screens long enough for those who weren't here on Monday, so you're able to copy it down. But yeah, so the thing we're gonna get started on Monday is this thing called Docker Compose. So like I mentioned on Monday, a lot of apps can have multiple images associated to it, right? So again, going back to something like Google Maps or Ithaca Transit, right? Some sort of map app has a distance calculator, right? Like how far you are between 2 points. Maybe has an API to collect bus times, right? Maybe has some sort of satellite view or like a map view, right? So it has a lot of different components, and each of them would be contained within one Docker image. And one app can have multiple images to it, multiple components to it. And this way we kind of segment each functionality into one image so that when something fails, we know exactly where it failed and we can look into the problem more specifically than just oh no, my whole app crashed. What is wrong with it, right? But again, for this class, we're only going to be using one Docker image, and we're going to be defining how to run that Docker image in this Docker Compose file. So if you remember from Monday, the way we run a Docker file, or a Docker image, rather, right, is by typing docker run -p, the port that we're going to be taking the Docker image from, the port that we're mapping it onto on our computer, /it, and then the name of the repository. So I'm not actually going to type in a valid repository here. But you can see here that Docker, while Docker run is standardized across any kind of programming language, it's still a lot to remember. It's still pretty verbose, right? It has 8,000 to 8,000 and -it. So the way we can actually we can just tell Docker how to run these images is through the Docker Compose file. So all right, let's start typing out this Docker Compose file. Okay. The first thing we're going to do is just say that this version is 3. This will just be the same across all of your Docker images. Don't worry too much about the details of this. The version we're going to be using is 3. The next thing is to tell Docker, or tell this Docker Compose file, which Docker images we want to run. And the way we do that is by typing services and typing the name of the service that we want to use. So, right, so if like, let's say I have Ithaca Transit, right, or like Google Maps, maybe these service names would be like bus time collector or like map view or something, right? Like all of these would have like different components and you would give names to them. But since I'm just doing demo, I'll just call this demo. So that's the name of our service. And then we tell the Docker Compose file which Docker image we want to run. So the way we do that, right, is by typing image and then the name of the image. Anyone remember how to list out all the Docker images in your terminal? What is the command? Is Docker something? Docker images, yeah. It's Docker images. So Docker images lists out all the Docker images that we have on our computer. And you can see here that we have 4 demo files with like all of them have like different versions, like we demonstrated on a Monday. And you know, like an associated size and whatnot. So the one we want to use, let's just say, is the latest version of Snejima demo 5. So the way I can specify that here is just by typing the name of the image. And another thing we can define is like what port we want to run it on, right? So we can see here that, you know, on we want to map the port 8000 in our Docker image to the 8000 on our actual computer. And we can just do the same thing here by doing ports and then a dash and then the port numbers that we want, 8000 to 8000. One super important thing that I probably might have to mention later on is if you don't have your Docker Hub username behind your Docker image, you're going to be able to run it on your local computer, but when you upload it to Docker Hub, it's not going to show up. So make sure, please make sure if you have a Docker Hub account, well, you're going to have a Docker Hub account for your assignment, but if you do have one right now, make sure you prepend your username followed by / and then whatever you want to call your image. Okay, everything good so far? That makes sense? Awesome. So from here, we kind of reduce down the verboseness of this Docker run command, right? We have this 8000, 8000, we don't need that anymore. We also have the repository name here. We already defined that here. So to run a Docker container, right? To start a Docker container from a Docker Compose file, all we have to do is do Docker Compose up. And now our Docker container is now running. So let's go to Postman. And if we hit one of the endpoints from demo 4, right, you can see that the Docker container is successfully ran. Can everyone see that? That makes sense? Yeah. So this is like even more convenient, right? Just like, you know, we simplified the pip install in Python app.py to Docker run. Now it's just all the way down to Docker up or Docker Compose up. And you can see here that if I have a Docker, if I run Docker Compose up, right, my terminal gets clogged. And on like a production computer, right, maybe you want to run some other commands while your Docker container is running. So the way we tell it to run our Docker container without actually having it clog up our terminal is to type Docker Compose up followed by a flag -d. That's short for detached, and it allows us for the container to be running in the background. So now the container is still running, right? It says starting src demo 1. And I can hit these endpoints, but it's not actually clogging up my terminal. So this is what you would want to do on your production machine, on your production computer. Cool. And again, the way you can list what Docker containers are currently running is by doing Docker PS. So let me kind of shrink this terminal a little so it's horizontal. Right? So Docker PS will show us all the Docker containers that are running, the ID, the image that it's running from, when it was created, and so on. And Docker images is right to like list the images. So those are some distinctions that you should know. And you might be wondering, like, okay, so I have this Docker container running, right? How do I want to stop? How can I stop it? That's just by typing Docker compose down as opposed to up. This will take down the container, and it does the reverse of what Docker compose up would do. Okay, does that make sense? Yeah. Cool. If that is all good, sure. 6. Okay, I do want to introduce one more thing that we used to introduce a week later, but might as well just introduce them now. The environment variables, right? We covered those on Monday. Does anyone remember what environment variables are? Yeah. Mhm. Right. So, yeah, that's close. I think you are like, you understand it, but yeah, I might not be explaining it like fully. Environment variables are, you know what variables are, right? Like in every programming language, there's variables and values associated to a variable. Likewise, you can set environments, or you can set variables within like your working environment. So what that means is that your computer itself has like its own like environment going, and you can set variable names there. And why that is useful is because let's say we're trying to log into a service on the backend, right? Let's say we're trying to use like some sort of tool that requires a user password combination. We don't want to post our user password combination on our code because then that will be uploaded to GitHub and for everyone to see. Or it'll be in our Docker container and people can install our Docker image and people can install a Docker image and so on. And that's problematic, right? So what you actually, the workaround around that is to create an environment variable where you define like variable names and the value associated to them and just like let your computer read the variables from there. So the way we do that is by creating an environment variable file, which is traditionally called .env. And in our .env file, we define variables and their values just as in like key value pairs with just like the variable name equals and then some value, just like you would in a programming language. So let's say my name, right, is like Shango, for example. And like net ID is like SN685. And a lot of the time, your environment variables will be capitalized. That's a traditional standard. So just keep that in mind. And the way we can specify in our Docker compose file which environment variable to use is just by typing env file is .env, which is the name of our file. Okay. So the rest of the demo is actually, or like in the past has been like pretty short. Yeah, the only thing like we have to do from this point onwards is to like upload it to Docker Hub and like, demonstrate that it is on Docker Hub, right? You can push it to Docker Hub and other people can pull the image. But just to take a bit of workload off of that, now next week, let's dive into like actually using these environment variables, right? So if we go to app.py and we go to our base endpoint, right, there's nothing defined here. So let's create a function called greet user or something. And endpoint for greeting user by reading the name of the .env file. Okay. So the way we read environment variables is by importing a library called OS, operating system, right? So your Mac or Windows. So let's do that at the very top of our app.py file. And then if we scroll down to our greet user endpoint, we can just do return hello. Okay, let's make this an F string. Hang on, I'm just F string. F. I think it just is this. No. It might just be this. Hello. Oh, it is. Okay. os.environment and a name. Oh no, that doesn't work. Oh, right here. Okay, I'm just gonna use the older way of combining strings. os.environment name. So now this is reading the environment variable called name, right? And taking the value and like printing it. So obviously this is not a traditional way of using environment variables, but if you have like secret values that you want to be using in your code, the only thing you'll be exposing is the variable name and not actually the value of it, right? So if you have like secret values, this is when you would actually use it. Okay, does that make sense? So from here, if we just do Python 3 app.py, oh, I don't have a, no, I don't. I'll have to make another virtual environment. tv.py. Oh, what is this? Okay, so right, if we try to hit the base endpoint, we're trying to return hello plus the environment variable name, right? But that environment variable hasn't been defined because I didn't actually like specify in my computer that I want to be using this .env file. However, in our Docker compose file, we did specify that, right? That we want to be reading from the .env file. So if instead I made a Docker container, demo 5 env or something. If I made a Docker Docker image with all of these files, including the .env file, and then we do demo5/env docker compose alt-d. Then if we hit this endpoint, we can see that the environment variable was successfully read. So I don't know if that was a little confusing, but hopefully that made sense. If you need to use secret values in your code base, please do not expose it to the internet. That would be pretty bad. Okay, back to the traditional demo. So now that we have right a Docker container running and a Docker images associated to these containers, another thing I want to show is how to actually go into these individual containers. So let's say one of your container goes down and you want to see what's wrong with it, right? Then you can actually go into like the terminal of like each of these containers. And the way we do that is by typing docker exec /IT. So this stands for interactable. Your container ID, and then bash, which is the type of terminal or like script we're going to be using. So now, right, if you look at the very bottom, we're in the user/app directory, right? That's the directory that we defined in our Dockerfile that we want to be setting as like our working directory. And if we do ls, which is like to list all the files in this directory, you can see all the files were copied over successfully and in our Docker container. So that's just a little way of like going into the terminal if you want to debug anything that's like seriously problematic. You'll usually get like terminal outputs, right? But since they're in Docker like containers, it's not going to go to your computer's terminal output, but rather the containers. So you'd have to like log into that to see. And the way you exit is just by typing exit. Okay, finally, let's demonstrate pushing to Docker Hub, right? This image that I created. So it should be signed in. Yeah, okay. So we have two images that are already pushed by me from like when I taught this course last semester, right? The deployment demo and like demo 8. But let's go ahead and push this demo 5 Docker image that we have. So the way we do that is by first typing Docker login. So this will allow your terminal to like log into the Docker kind of like service. And as long as you have the Docker app running and you're logged in there, this shouldn't ask you for your credentials. Then if we type Docker push, that's Najima demo 5. Yeah, let's just push like our usual demo 5 or like our base demo 5 image. If I push that, you can see all this stuff is running. And after we wait for a bit, we should be able to see in Docker Hub that, right, this demo 5 image has successfully been pushed. So next week, we're going to cover how to deploy our apps, meaning how to make it publicly accessible for like, your friends to use or like your family to use if they need a to-do app made by intro to backend students for whatever reason. But right, in order to do that, we have to actually deploy our service, right? Like put this on the public internet for people to access. And the way we're going to actually have another computer, have a server running our code is, right, one way is like to push it out to GitHub and have it pull code from GitHub and do all this setup there, right? But the better way is to like containerize it into a Docker image, have the Docker image be pulled instead on the server's computer, and then you run the Docker image into a Docker container, which will then be publicly accessible. Yeah, so that's the stuff we're going to be covering next week. But right, so we demonstrated how to Docker push, right? Docker pulling is like basically exactly the same. Docker pull, and then some sort of image name, right? So that image name, the one demonstration I have here, one like image I have ready here is whale say. This is one of the, I think. Full access knife for whale say. Much. Oh, do I have to say Docker/whale say? Oh, nice. So yeah, so just like I was able to like push an image to Docker Hub, I can also pull an image from Docker Hub, right? Whale say is like one of those images that's like kind of used for demonstration purposes a lot of the time. And what I can do with whale say is Docker run. I have to specify that I'm running this on like a Linux kind of container because I'm on an M1. You'll have to do this if you're on an M1, but otherwise don't worry about it. And then I can type Docker/whale say, the image name. And then these are just like some demo commands that you can run. So this is a Docker container that when you run the or Docker image where if you run the container, it like prints a little cute whale or Docker whale and then types boo. So that's kind of cool. But yeah, I know it was really short. I guess we like kind of went through Docker pretty quickly on Monday, but that is actually it for demo this week. So yeah, does anyone have any questions about like containerization at all? Do people understand it? 2 questions. Yeah, you can start. How do you make a Docker image? Good question. We'll have like, I think in our slides, which is on the website, The last slide is like a list of all useful command. I forget. I can change that, but you just type docker build -t and then the name of like your repository. So like your thing, right? That's Dejima demo 5. And then you can also like specify a version after the colon, so like version 2. And then where you want to build your Docker container or Docker image from. So like dot, which is the current directory. I know there was another question. Do you have a question? Oh, that was a question too. Okay. Did Docker make sense? That was shockingly easy. Yeah. Yeah. So I don't know how else to explain this, but like the reason why Docker is just so useful is because, right, if you have only a Docker file, then you would have to like Docker run and like run some sort of command, right? If you have a Docker compose file, it's Docker compose up, right? And those two commands are probably easier to memorize than like having to memorize like individual setup steps for like every single type of project in like any language and any framework, any library kind of thing. So that's why we teach Docker. It's like a standardized way of like running software. Yeah. Anything else? So this week's PA5 is going to be extremely easy. All you have to do is push an image to Docker Hub. So hopefully that is relieving. I know this semester has been hard. But yeah, if there's no other questions, we can get started with the Kahoot and just like leave the rest for PA4 questions because I might be able